Hey kiddos, today we are going to be talking about alternative solutions for solving equations. So normally when we solve an equation, we get one solution and that works for us because that's all we're looking for. So as a reminder, a solution is a number that makes the equation true when you plug it in, substitute it instead of the variable. So for example, on this example right here, if I'm telling you x equals 2, then that means I can substitute that value in for x into the original equation, and I would get 3x, so that's 3 times 2 plus 4. Does that equal 10? 3 times 2 is 6, plus 4 does equal 10. And so this works out. And that's exactly what I want. When I'm looking for a value of x to be the solution to the equation, I'm looking for the number that I can plug in to make the original equation true. Okay, but that doesn't always happen. There are certain circumstances where we might not get a solution, or we might get an abundance of solutions. We might get a bunch of answers. Okay, so there are 3 different possibilities, and we're going to explore those today. The first one is what we're used to. That is when you have one solution, for example, x equals 2. And special cases, which is what we're talking about today, the first one is no solution. That's when no matter what, no matter how hard you try, you can't find an answer for that equation. There's no value that you can plug in to make it work. That's when you get something weird at the end, like 5 equals -8, which we know is not true. And then our third possibility is infinite solutions are all real numbers. And what that means is that already from the get, all of the equations are balanced, they're equal, and no matter what number you pick, it's always going to work. Okay, I can pick any number I want, I can substitute that value in for x, and it will work no matter what that value is. Okay, so these are the possibilities that we're going to be exploring today. So our first special case is when we have no solution. And again, that is when the last line of work is not true or doesn't make sense. So for example, if I'm working out the solution to an equation, I'm solving for x and I get 5 equals 9 at the end, we know that's not true. So this has no solution. And the symbol that we use is a circle with a line through it like that. And that's called the empty set or the null set. Or you could just write out, again, no solution. So the symbol is just a real nice shortcut to not having to write no solution. So again, this is a possibility. It is a rare possibility, but it is a possibility. And now we're going to look at an example of an equation that has no solution. So before we can start working this problem, we do have to clean up something. The left side is fine, 3x plus 2. I'm just going to write that down again. But on the other side, we have some terms that can combine together. The 2x here and the x are going to combine to make 3x, and the plus 7 is just going to tag along. Now, right off top, I do notice some real weird stuff going on. I have positive 3x on both sides. So I know that my next step is going to be trying to move all the x's to one side. But when I do that, when I subtract 3x from both sides, okay, the x's cancel, and the only thing left is 2 equals 7, which I know is not true. So that means that this has no solution. Okay. And again, what that means is that no matter how hard I try, I can't find a value of x that's going to make this equation work. So there is no solution. Okay. Our next special case is infinite solutions, or all real numbers, meaning that no matter what number I pick, if I plug it into the equation, it's going to work. So we know that we have infinite solutions, or all real numbers, when the last line is always true. I get something like 7 equals 7 or x equals x. And the symbol that we use for this is going to be an R with a second line in there. Okay? And again, it stands for all real numbers, meaning that I can choose any number that I want, any number on the real number system that works, and I can plug that in, and the equations will balance out and be equal. Okay? Let's look at an example of an equation where the answer is all real numbers. So again, I have to do some cleaning up here. I have to clean up the left side by distributing. 4 times x is 4x. 4 times 2 is going to give us 8. On the other side, I have 4x. Then I'm going to combine like terms. 5 plus 3 is going to give me positive 8. And I can look at this and I can say, whoa, those are the same exact thing. And I can stop there. Right away, I can tell that the answer is going to be all real numbers because these are literally the same equation. Okay. But if I wanted to take it one step further, if I wanted to keep going just to prove to myself that the answer is actually all real numbers, I could subtract 4x from both sides. And if I do that, I get 8 equals 8, which I know is true. That's always going to work. So that means, again, that I can pick any number I want. It doesn't have to be 8. I can pick any number I want and plug that in, and the equations will work. Okay. Now, I have 3 examples, and this is our task. We have to determine if the equation has one solution, which is what we're used to. That's when we get like x equals a number. If it has infinite solutions, and again, infinite solutions means all real numbers, so we're going to be using that fancy R. And then no solution, and again, that's when the last line doesn't make sense. We can't find an answer that's going to work, and so we're going to use that 0 with the slash through at the empty set. Okay, so let's look at our first problem. We got some cleaning up to do. On the left side, I have to distribute. So 3 times x minus 3 gives me 3x minus 9. And on the right side, I have to combine like terms. 2x and x makes 3x. But then I have positive 9. Now, certain students will look at this and they'll think, oh, those are the same thing, but they're not paying really close attention, and they're not going to see that negative 9 and positive 9 are definitely not the same thing. So we have to keep going. I'm going to subtract 3x from both sides. Okay, now when I subtract 3x from both sides, I get negative 9 is equal to positive 9. Now those are not true. Okay, negative $5 owing someone $5 is not the same thing as having $5. So negative 9 and positive 9 are not the same thing. That is not true. So our answer is going to be no solution. Okay. Second example, again, determining if there's one solution, no solutions, or infinite solutions. We have to clean up the left side a little bit just by doing some distribution, simplifying that out. 3y, 3 times 4 is positive 12. And on the right side, we can just bring that down. 2y plus 12 doesn't need any work. So looking at this, I can already tell that there's going to be one solution because our y's don't match. The y's don't match. So this is just a regular problem. We're going to go about our normal business. So I'm going to subtract 2y from both sides. 3y take away 2y is just y plus 12. And that equals 12. Okay, I need y to be isolated, so I'm going to subtract 12 from both sides. And again, this is where some students feel like they made a mistake. So y comes down, and 12 minus 12 is just 0. Now again, students always feel like when they get 0 that they made a mistake, but 0 is a perfectly fine answer. What that means is that if I plug 0 into the original equations instead of y, that they'll be balanced. They'll be equal on both sides. That's all it means. 0 is a possibility. It doesn't mean you made a mistake. It's just a number that we don't often think about as being a solution. So 0 is perfectly fine as the answer. Okay, last one. Here we have a fraction, which again, some students get intimidated by, but don't. Just think about what the fraction actually means. So on the left side, we are going to distribute. We have 4 times x, which is 4x, and 4 times negative 3, which is negative 12. When I distribute this 1/2 through, it just means take half of whatever you're multiplying it by. So 1/2 times 8x, half of 8 is 4, and the x is going to tag along. Half of negative 24 is negative 12. Now looking closely, I can tell right away that these are the same equation, so I could stop right here, all real numbers, okay? But if I wanted to keep going just to make sure and confirm for myself, I'm going to subtract 4x from both sides. Okay, and then negative 12 is equal to negative 12, which we know is always true. And so this is all real numbers, meaning again, I can take any number on the real number system I want, I can plug it in to the original equations, and it will work. They'll be equal on both sides. Okay, so nothing really new about what we learned today except for our two special case outcomes, no solution on all real numbers. Aside from that, all the work we've been doing is exactly like what we've learned already when solving equations. We're distributing, we're combining like terms, and then we're working backwards to solve for the value of x if we can find one.